Okay, it depends on the data set. If you are if you are considering a sample, the standard deviation of a sample. If you are considering the population, that is the standard deviation of the population. Simple, no? Yes. Measure of shape. What is measure of shape? Measure of shape. What do we have? Skewness and kurtosis. What is skewness? What is skewness? Tails. Is this positive skewness or negative skewness? Positive skewness. Why? Because the tail is towards the right side of the mean value. Okay. And negative skewness looks like this. Okay. Tail will be towards the left side of the mean value. Okay. Next, kurtosis. Skewness talks about the tail. Kurtosis talks about the height of the curve. Okay, height of the curve. How many things do we have in kurtosis? Three. What are they? Leptokurtic, platykurtic. Next, mesokurtic. What are these things? This is our normal distribution. Okay. Another one is this one. Next, another one is this one. Which one is mesokurtic? Which one is mesokurtic out of these three? 1, 2, and 3. Meso. Kurtosis greater than 0. Kurtosis less than 0. Kurtosis exactly is equal to 0. That will be mesokurtic. Okay. So the middle one, second one. Which one will be lepto? Kurtosis greater than 0 is lepto. This is platy. This is meso. Okay. Next, what else have we discussed? What else yesterday? Standard error. Okay. Can someone tell me what is standard error? First, tell me what is sampling error. Sampling error. Sampling error. Difference between sample mean and population mean. Sample mean minus population mean. That is nothing but sampling error is simple. X bar minus mu bar. Right? What is X bar? Sample mean. What is mu bar? Population mean. Now what is standard error? Standard error. Tell me this one. Standard error. Or at least the formula to calculate standard error. Formula to calculate standard error. Standard deviation divided by under root of n. Now tell me the definition of standard error. All mean of sample minus population mean. No. Standard error definition.
That is samples in population. The deviation in the all the samples.
Deviation between all the sample means. Okay. Yesterday we have seen if you have 1000 data points in a population and that is divided into 30 samples. Okay. And if we take means of 30 samples, okay, the values will be definitely different, right? If we plot that on a graph, okay, first sample mean might be here, second one, third one, 4, 5, 6, 7, 8, 9, 10, like this we have 30 sample means, right? And if we take average of all of these sample means, that lies somewhere here. This is the average of 30 30 sample means. Okay, average of 30 sample, that is mean of 30 sample means. Now the deviation between this mean and all the other data points is nothing but standard error. Okay, how can we calculate that? Standard deviation divided by under root of n. Is this understood? Yes or no? Next, what else have we discussed? What else? IQR. What is IQR? Where is population mean? In standard error, there is no population mean. It is sampling error. In sampling error, we have population mean. Sample mean minus population. Standard error is different. Sampling error is different. Yes, what is IQR? What is IQR? Interquartile range. What is that? Interquartile range? This talks about, this tells about middle 50% of data points. Meaning of this, our formula to calculate IQR, Q3 minus Q1. What is this Q3 and Q1? What is this Q3 and Q1? IQR, the whole data set will be divided into 4 parts. Okay. This is 25th percentile. This is 50th, 75th, 0th, and 100th. Okay, 100th percentile. Meaning of this 25th percentile? Q1, Q2, Q3, Q4 maximum value, that is fine. Next, meaning of this Q1 or 25th percentile? These are the positions. Okay, Q1 is position, Q2 is also position, Q3 is also position, Q4 is also position. But we need to find the value that is present at that position. Okay, to calculate IQR, we need to find the value that is present at this Q1 position and Q3 position. How can we get that value? Q1 is equal to, how can we find out this? N plus 1 by 4. I mean 1 by 4 into n plus 1. Simple. Next, Q2, n plus 1 by 2. Q3, 3 into n plus 1 by 4. Next, Q4. Okay. Maximum value 100%. Okay. Next, what else have we discussed? Anyone? What else? Outliers. Okay. What is an outlier? What is an outlier? Anyone? What is an outlier? Extreme value which is different from others. Yes, exactly. Which is significantly different from others. How can we calculate outliers? How can we check if there are any outliers or not in our data points? Lower bound and upper bound. Formulas for lower bound? Q1 minus 1.5 into IQR. For upper bound, Q3 plus 1.5 into IQR. Okay. Did anyone try yesterday's task? Did anyone try yesterday's task? No? Why no? Okay. Have some work. Okay. No issues. Now see. Okay. What was the yesterday's task? What was the yesterday's task? What is the question? I'm asking about the question. Answer we'll discuss anyways. Which one, Naresh? Which one? Why do we need that, sir? Which one? Standard error. That is a parameter. JK. Okay. See here. Understand. Sales I will just write. Rand between. Okay. 1000, comma 2000. Okay. I'll just copy this one till here. Okay. Example, this is 5000. This is 7000. Okay. Now see here, if we have that simple data set and we want to find out if there are any outliers or not in this simple data set. Okay. How can we do this? First, we need to find IQR. Then we'll be able to find lower bound and upper bound. Yes. To calculate IQR, what do we need? Q3 and Q1 value, right? How do we get Q3? Q3 equal to 3 into n plus 1. What is n plus 1? How many data points do we have? 13 plus 1, 14 divided by 3 into 14. What is this? Okay, 42 divided by 4. What is the value? 10.5. That is Q3 value, right? Now see. What is that 10.5? What is that 10.5? Position. 10.5 is Q3. That is 75th percentile. That is the position. That means in this 13 data points, the value that is present at 10.5 position is our Q3. Okay. 10.5 position. How can we check what is the value at 10.5? 10th value is this one, right? 11th value is this one. What will be the middle value with this 1700 and 1100? Okay. Manual calculation. We can do like that, or simple we have Excel formula, that is quartile.inc. Quartile.inc, open brackets, it is asking for array. I'll just select this whole thing, comma, which quartile do we want? We want third quartile value. Okay. Quartile.inc is to check what is the value that is present at any of the quartile, Q1, Q2, Q3, and Q4. Now, if you just click enter, the value that is present at Q3 is 1669, right? Is this understood? Yes. Next, Q1, same, quartile.inc, array, I'll select this one, comma. Now what will you do? 1, because we want first quartile. Enter. This is the value that is present at first quartile. Is this understood? Yes or no? Yes or no? When can we calculate quartiles? When can we calculate quartiles? When will we calculate median? Median. When we need to find middle value. Before finding that middle value, there is one more small step that we need to do. What is that? Sorting. Here also, while calculating quartiles, first the whole data set should be sorted in ascending or descending order. Okay. Then we'll be able to calculate the quartiles. Okay. Is this understood? Yes. Now see. Sort. Smallest, largest. Now see, once sorted largest to smallest, then we'll be able to calculate quartiles. We have got Q3 value as 1669, Q1 as 1116. Okay. Now what is IQR? IQR? Q3 value minus Q1 value, that is this value minus this value. What is that? 503. 503 is what? IQR. That means range of middle 50% of the values. Is this understood? Yes or no? Should I repeat? Should I repeat? Simple thing. How do we calculate? We know how to calculate Q3 and Q1. Okay, I'll just delete this one. We know how to calculate Q3 and Q1. Okay. Now what is IQR? It talks about middle 50%, right? IQR range. R is nothing but range. What is that range? 503. Range is nothing but maximum value minus minimum value. If we take only, okay, let us go here. Now see, here somewhere it will be Q3 value. Here somewhere it will be Q1 value. Generally, how do we calculate range? Maximum minus minimum value. Correct. Now in the interquartile range, if we just do Q3 value minus Q1 value, that also becomes range. Q3 minus Q1. Now this is the range of middle 50% of the values. This range is for the whole sample or whole data points. Is this understood? Yes? Now. See here. Okay, we have got the IQR. Next, how to calculate lower bound and upper bound? Okay, let us calculate here first. Or else let me insert a line chart first. Okay, these are our sales values. Now we just want to find what is, if there are any outliers or not in this. Okay, now I'll just write mean value on the line chart. We want to show mean at the same time lower bound and upper bound. Lower bound and upper bound. Okay, now what is mean? Average of all of these values. Add dollar symbols so that range is fixed. Okay. Same value, just copy paste as values. Next, now lower bound equal to Q1 1166 minus 1.5 into IQR value 503. Okay. Enter. You'll get to see 411. I'll just copy this. Okay. Why are we getting zeros? Why are we getting zeros? We need to add dollar symbols. Where should we add dollar symbols? Where should we add dollar symbols? For? For? Where should we add dollar symbols? IQR. Here. Okay. I'll copy this, paste it over. What did we get? Now where to add dollar symbols? Where to add dollar symbols? J2 also. Dollar J $2. Okay. Now if you just copy this, you'll get to see the same value. Now upper bound equal to Q3 plus 1.5 into IQR. Okay. Dollar, here also dollar, here also dollar. Okay, we have got our lower bound and upper bound. Any value beyond these values will be considered as an outlier. How to show this same thing on the visual? How to plot this on the visual? Yes. How to show upper bound and lower bound on the visual? Click on chart and just drag this blue line till the end of the data set. Now we'll get to see upper bound and lower bound. Is this understood? Yes or no? Okay. This chart title not needed, error bars, grid lines, legend. Okay, legend. If you see, blue line indicates sales, our sales values. Orange indicates average mean value. This gray color indicates lower bound and this orange color indicates the upper bound. Any value beyond this gray and orange line will be considered as an outlier. Is this understood? Yes or no? Okay, now let us change the value. For example, I'll change this to 3000. Okay, 3000. If you see, again, the point is beyond this orange line, so it will be an outlier. Same thing. Is this understood? Yes. This is IQR. Next thing that we'll see is box plot. What is box plot? What is box plot? Okay, I'll just copy the same sales data. Paste it here. What is box plot? Box plot. Anyone? How does it look? Box. It looks something like this. Candle format. Correct, exactly. Okay, this is a box plot, and exactly in the middle of the box plot, you will find median value. Okay, this is Q1, this is Q3, this is obviously Q2, this is Q0 or minimum value, and this is maximum value. Okay, if we just insert box plot, it by default calculate IQR everything and shows us the outliers like this. Now see, I'll change this to 1600 watt. I'll just select this data, insert. Where is this? Histogram. Okay, box plot for this. What is it showing? Do we see a box here? Or else let me change the values. 7000. I'll change this to 5500. Do we see the box plot? Yes. Here is the. Okay. Now see, this bottom line that we have here is the minimum value. Okay. Middle we see a small line here, thin line here in the blue color shade, right? That is the median value. And this top line that we see here is, what is that? Maximum value in our data set, and all of these are outliers. The point that we see beyond that maximum value is nothing but outlier. I hope this is understood. Okay, if you see the data labels, see 3000 and 5000 are the outliers, and these are the values. Minimum value 1033. First value after sorting in ascending order is 1033. Q1 value, Q2 value, Q3 value, and all the other values. Okay. Is this understood? In the box plot, this is the box, and this line and this line here are called whiskers. Okay, whiskers. Is this understood? Yes or no? Okay. Shall we move on? Online participants, shall we move on? In whiskers include maximum. Yes. Okay. All right. Next thing. A small thing. Empirical rule. I think I've already said about this. What is empirical rule? In whisker include maximum and minimum. Yes. What is empirical rule? I've already said this. What is empirical rule? 68, 95, 99.7%. Okay, this is called empirical rule or 68, 95, 99.7 rule. What does this rule say? 68% of the data points lie within one standard deviation from the mean. Okay, plus or minus 1. Okay, next, 95% of the data points lie within. Excuse me. Okay, 95% of the data points lies within plus or minus 2 standard deviations from mean. Okay, next, 99.7% of the data points lie within plus or minus 3 standard deviations. Is this understood? From mean. Okay, meaning of this, if you just have a normal distribution, how? Naresh, that is not a question. Okay, how is not a question? Now understand this one. If this is our normal distribution curve, bell curve, and here is the mean value, empirical rule states that 68% of the values lies within plus or minus 1 standard deviation from the mean value. Okay, from the mean value. Next, %95 of the values lies within plus or minus 2 standard deviations. Plus 2 standard deviation. And 99.7% of the values lies within minus 3 standard deviation and plus 3 standard deviation. Okay. Is this understood? Anything that is beyond plus 3 or minus 3 standard deviations from the mean is an outlier. Simple. Okay. Yes or no? Yes. Here we have a small thing that is Z score. Anyone know what is Z score? Anyone know what is Z score? No? Z score is used to check if a value is an outlier or not. Okay. Z score value. This is the parameter that we use to check if a value is outlier or not. Formula for Z score is equal to value minus mean divided by standard deviation. Value minus mean divided by standard deviation. Let's take a small data set and see an example. Now understand this one. Our data set, for example, 100, 200, 300, 400, 500, 700, 10,000. Okay. 8,000. Okay, if this is our sample data set where we have 100, 200, 300, 400, 5, 7, 10,000 and 8,000, and we want to check if any of the value is an outlier or not. Okay, then how can we check this using Z score? First, we need to find what is mean value. Then we need to find what is standard deviation value. What is mean of, for this data set? What is mean value for this data set? 100, 300, 600, 1,000, 1,000, 1,500, 2,200. 20,200 divided by 1, 2, 3, 4, 5, 6, 7, 8. What will be the value for this? value for this somewhere around, sorry, somewhere around 2500 or approximately 2500. Can someone tell me the exact value for this? Calculator. Exact value for this. 2550. 252. 25? 25, correct. Okay, 2525. 2525. This is our mean value. Standard deviation, how do we calculate? Standard deviation is equal to under root of variance. What is variance? Variance, summation of x minus x bar whole square divided by n minus 1. If we substitute all the values, okay, this is a big data set. How will this look? 100 minus 2525 whole square divided by 7. Okay, the whole value will be like this, plus 200 minus. Can someone calculate this quickly and tell me the answer? Square plus 400 minus 2525 whole square. Take 1 minute, 2 minutes, whatever it is. Tell me the answer for this. 500 minus 2525, sorry, whole square plus 700. Is it 700? 700, 10,000, 8,000. 700 minus 2525 whole square plus 10,000 minus 2525 whole square plus 8,000 minus 2525 whole square, whole divided by n minus 1, that is 7. Just calculate this and tell me the answer. What is variance value? Value after this.
Who is going to explain the topic today?
Yes. What is the value? More time. Okay. Take 2 more minutes and tell me the value. Online participants, what will be the value for this? You got? Too long. Standard deviation 9365.8. 16290,715. Is this the variance value? No. What did you get? Variance value is minus. It will not be minus. 100% it will not be minus. That will be plus value only. 3822. Okay. Why are we getting different values? Understand this. Standard deviation and variance value both will be positive only. We will not get negative values. Huh? Standard deviation 4036. 9365. I have got 3 answers for standard deviation. 4036, 3822, 9365. How are we calculating? How are we calculating? Tell me that first. 100 minus 2525 minus 2425 minus 2425 whole square. We'll get some value. Put that aside. Again do 200 minus that one. Again do 300 minus that one whole square. Then add every value. Okay. Forget about it. I understood. Forget about it. Example. Now here see. For this data set or for any other data set, okay, it is taking time for the calculation. So let's take an example. Variance value, for example, variance 100. Okay, let's take variance is equal to 100. What will be the standard deviation? Variance equal to 100. Then what will be the standard deviation? Just one more example. I mean, simple one. Variance equal to 100. What will be the standard deviation? Under root of 100. What is under root of 100? 10. Standard deviation is equal to 10. Variance is equal to 100. Okay, forget about variance. Standard deviation. Now the Z-score formula is value minus mean value divided by standard deviation. For example, our mean value is somewhere 70. And we are checking if 200 is an outlier or not. Okay, 200 minus 70 divided by 10. What will be the value for this one? value for this one. Value for this one? 13. Okay. Z score is 13. Meaning of this, the value 200 is present at the 13 standard deviations from the mean. Understand this one? If Z score value is 13, that means the value that we are taking 200 is present at the 13 standard deviations far away from the mean. Is this understood? Okay. Okay, fine. Whatever it is. Okay. I'll repeat this again. Z score is equal to 13. Meaning of this, the value that we are taking while calculating Z score is present at 13 standard deviations far away from mean value. Meaning of that, the value that we have taken is an outlier. Why? Because any value that is present beyond plus or minus 3 standard deviations is an outlier. Okay, any value that is present beyond minus 3 and plus 3 standard deviations from the mean value is an outlier. Okay, okay, one more thing. Z score, after all the calculations, we have got Z score is equal to 2. What does this mean? Mean value is equal to 70. Standard deviations, we have got 10. Value that we are checking, for example, 90. Okay. What will be the Z score for these values? Value minus mean, 90 minus 70 divided by 10. How much is it? 2. If our Z score value is 2, what does that mean? The value that we are taking, 90, is present at 2 standard deviations far away from the mean value. Is this understood? Yes. So 90 is an outlier or not? Not an outlier. Why? Because it is within plus or minus 3 standard deviations from the mean value. It will fall somewhere here because it is plus 2. And anything beyond plus 3 and minus 3 standard deviations, we'll consider that as an outlier. Okay. Is this understood? Yes. If this is understood, next thing. Covariance. Anyone know what is covariance? Anyone know what is covariance? Yes. Then what is covariance? Direction. See. What is how many relationships do we have? How many relationships do we have? While we are learning about scatter plot, we have seen different types of relationships. How many kinds of relationships do we have? Direction of the variable, correct. Different kinds of relationships. Sorry. I'll come back to this covariance. Types of relationships. How many do we have? Linear and non-linear. Okay, linear and non-linear. In linear, straight line, this is positive. Straight line, this is negative. Okay. And for no relationships, there will not be any line. All the data points will be scattered like this. Okay, no relationship. What is non-linear? Exponential. Okay, this is positive non-linear, this is negative non-linear, right? Now this covariance talks about the direction of the line. Covariance talks about the direction of the line. For a linear relationship, covariance talks about the direction of the relationship. Okay, direction of the relationship. Formula to calculate covariance. Covariance is equal to sigma xi minus x bar into yi minus y bar. Okay, whole bracket divided by n minus 1 again. What is this? What is xi? What is yi? What is x bar? What is y bar? What is xi? What is yi? X bar, y bar, and n. This is the formula to calculate covariance. What are these parameters? Xi, xi. Xi is nothing but value of x variable. Yi is nothing but value of y variable. Okay. Value of x variable. Value of y variable. X bar, mean of x sample. Okay. This is mean of y, n number of data points. Is this understood? Covariance is okay. Covariance. After calculating covariance, okay, after calculating covariance, if we get a positive number as output, positive number as output, what does that mean? That means it is a positive relationship. Positive linear relationship. The direction will be increasing direction. If we get a negative number as output, meaning of this negative relationship, okay, positive relationship, that means both the variables move in same direction. Okay, now see this one second. Negative relationship, meaning of this, both variables move in opposite direction. Meaning of this, same direction, that means both the variables are directly proportional to each other. If one increases, the other also increase. X-axis, y-axis. If one increase, other also increase. The line looks like this. Okay. Next, both moving in opposite direction. That means they are indirectly proportional. If one increases, the other decrease. If x-axis increase, the y-axis decrease. X-axis increase, y-axis decrease. Is this understood? Covariance tells us about the direction. Whether it is moving positively, that means whether the two variables are directly proportional to each other or indirectly proportional to each other. If you get positive number, that is positive relationship, meaning of this, both variables move in the same direction. If you get a negative number, meaning of that negative relationship, and both variables move in opposite direction. Now, what if we get covariance is equal to 0? 0, no relationship. Okay. Positive relation, directly proportional both variables. Negative, I mean opposite direction, indirectly proportional both variables. And 0, no relationship. Is this understood? Yes. Next. Correlation. Anyone know what is correlation? Correlation. Correlation. No? Okay. See here. Covariance talks about the direction. Correlation talks about the direction and also strength. Meaning of the strength? Meaning of the strength? whether it is a strong positive or whether it is a weak positive, whether it is a strong negative or whether it's a weak negative. Okay. Formula. And this correlation is range of this correlation is from -1 to +1. Okay, -1 to +1. That is -1 less than 0 less than 1. Okay. And the formula to calculate sigma xi minus x bar into yi minus y bar whole divided by under root of summation xi minus x bar whole square into yi minus y bar whole square summation. Okay. This is the formula to calculate correlation. And range is from -1 to +1. Meaning of this -1 to +1. For example, after calculating and substituting the data points, after calculating, we have got the output as -1. Meaning of this is strong negative relationship. Strong negative. Meaning of that? Strong negative. How strongly opposite direction? Meaning of this negative, -1, the range of correlation is -1 to +1. That means even if you calculate correlation for 100 times, the value will only be in between -1 and +1. If you get the result as -1, that represents strong negative relationship. Meaning of that? Meaning of that? -1. Strong negative. 0 to -1. This is weak negative. 0, no relation. Okay. 0 to +1. Weak positive. Exactly +1. Strong positive. Okay. If two variables are exactly 100% directly proportional to each other, that is strong positive. If they are directly 100% perfectly indirect, not directly proportional to each other, that is strong negative. If the value is somewhere between, for example, we have got the output as output value that we have got is 0.89. Meaning of this? 0.89. That is weak positive, and it is very close to become a perfectly directly proportional variables. Okay, 0.89. It is very close to +1. Meaning of this? It is almost there. It is 89%. It is directly proportional. Okay. Same if we get -0.89 or -0.9. It is a weak negative, but almost a strong negative. Okay. Is this understood? Yes. So this is covariance and correlation. By this, we are done with descriptive statistics. Okay. By this, we are done with descriptive statistics. And on Monday, we'll start with probability. And after this, inferential, where we have hypothesis testing, that is null hypothesis and alternate hypothesis. After this, Z test, T test, ANOVA, chi-square. Okay. Mostly by next Thursday, we'll be able to finish this statistics. Okay, Thursday or Friday. Mostly next week, we'll finish this statistics, and after that, we'll go to Python. Okay. Any questions till here? Anyone? Till here, if you know, somewhere in most rare cases, we'll be using this in data analytics till here. Beyond this, no chance of using any concept in the data analytics. Okay. After this, all of the concepts will be used in either machine learning or data science. Okay. All right. Any questions? If no questions, I'll stop it here for today. And let's meet back on
Monday.
Monday.
Happy.
Happy Friday.
Okay.
Okay.
Thanks
Thanks everyone. Thanks for joining.